I'm Shanti, a BTech CSC student, and today I'm excited to share one of my machine learning projects titled Loan Detection System. This project is a part of my Artificial Intelligence with Machine Learning course on the Pregrad platform guided by my mentor Mr. Saurabh Sir. I made this project because loan approval is very common real world problem. Banks need to decide whether a customer should get a loan or not based on their profile. So using machine learning, we can predict the loan status with good accuracy. In this video, I will walk you through the entire code cell by cell, loading the dataset, doing EDA, pre-processing, model training, model comparison, accuracy checking, and visualizations. So let's begin. First of all, I have imported all the important Python libraries like NumPy, Pandas, Matplotlib, Seaborn, and Scikit-learn. These are required for data manipulation, visualization, and building machine learning models. Next, I have loaded my dataset named loandetection.csv, which is the name of the CSV file, using pd.readcsv. Here it is, and this data source output as 41,188 rows with 60 columns. Now the basic EDA started. Df.shape tells us the total rows and columns in the dataset, which I have already told you about. This is the rows and columns, and here it is the output of that df.shape. Next, df.columns. As you see, all the columns are displaying in on the screen from this code. Next is df.info, which shows the data types and tells us there are no missing values in the dataset. See, now df.describe. This gives statistical summary like mean, minimum, maximum for numerical columns. Now we started performing that univariate analysis. This shows how many customers belong to each age group. See, 31, 32, 33, 36, 35, and these are the numbers of same age group. Now df.isNull.sum, which shows again confirming there are no null values. As you can see, 0, 0 is present in all the columns. So by the way, this I have done to calculate missing value percentage to double check that everything is clean or not. See, you can see the output, it's coming in decimal, right? Next is for correlation metrics. Now I'm checking correlation using df.correlation. This helps us to understand which features are strongly related to loan approval. This is df.correlation. Here is the output. Next, I have already told for missing null values. Now this is the box for box plot. I also used box plot to visualize check outliners in the numeric columns. These all are the box plot. Let's come to the code. Yeah, here it is. Now I have splitting features and target. This is the topic. X equals to df.drop. I separated features X and target variable loan status label Y. Hmm. I split my data into 80% training and 20% testing data using train test split function. Now feature scaling. I scaled my features using standard scaler. Scaling helps to improve the performance of models like logistic regression. Model 1 is the logistic regression. Wait a minute. This is the training and testing part. This is the model selection part. I trained the logistic regression model. This is a simple but yet powerful classification. This says the logistic regression model gave training accuracy 90%, testing accuracy 90%. This means the model is not overfitting and performs very consistently. Here it is written. Approx at 90%, right? 89 is given. This is now for the confusion matrix and report. Here is the heat map. Oh, I'm sorry. This is the confusion matrix. The confusion matrix tells us how many predictions were correct or wrong. The classification report shows precision, recall, and F1 scores. Model 2 is the random forest classifier. Next, I trained a random forest classifier model. This model performed with around 88.7% accuracy, slightly lower than the logistic regression in this dataset. Then show confusion matrix and classification report. Random forest has a bit weaker recall for class 1, meaning it's not great at predicting positive loan approval classes in the dataset. See, what I have said is displayed here. This is the end. This brings us to end of my loan detection project explanation. Through this project, I learned how to perform detailed EDA, handle large datasets, apply feature scaling, build and compare ML models, interpret confusion matrices and evaluation matrices, understand model behavior in real world use cases. This project really strengthened my understanding of AI and ML, and I want to express my special thanks to Pregrad for providing such an industry oriented platform to learn from, and to my mentor, Mr. Saurabh Sir, for his guidance throughout the course. Thank you so much for watching. If you found this explanation helpful, then do like. Thank you so much.